And when we see that it happens, we can fix cin. Let me show you how that looks. So here, cin is asking for a number, and if cin.fail, then I'm going to write a message, cout, you broke it, you monster. And let's run it and see what happens now. If I type 1, and 1 and 1, everything works fine. But if I type in X, right there, I broke it, I'm a monster. To fix it, all we have to do is tell cin to clear itself. It will forget that it's broken. But the input buffer will still have that X inside of it. So if I run this code, watch what happens. I'm going to put an X in here, and I broke it, I'm a monster, but then I cleared it. And then the next thing that happened is it asked, cin asked for a letter, and there was an X in there. So it grabs the X and puts it in letter, and now it's waiting for a decimal value. I'll just put a decimal value in here, and check that out. It broke when I was entering a number because X is not a number, it broke there. X is a letter. After it got that letter, it started working normally. After we clear it, we can pull all of the data out of the input buffer, and this is how we do it. cin.ignore 1024/n. What this line right here says is, hey cin, I want you to ignore everything in your input buffer at up to 1024 bytes. This, by the way, is a kilobyte of data. 1024 is a round number to a computer. It's 2 to the 10th power. So ignore a kilobyte or until you find the first new line character. So until the user pressed enter once. And now if I run this and I hit X like this, it recognized that I broke the number input. It cleared the brokenness, it ignored the X, and now it's waiting for another letter. And I can put another letter and another number, and there's the other number. So now we know how to catch it if it breaks, and how to continue working with the once broken cin. But how do we get it so that it'll ask us to enter this number again? Well, let me show you how to do that. One easy way to do that is with a loop. And a good loop for this situation is a do-while loop. While cin.fail. Alright, so I'm going to move this around a bit here. I'm going to take this prompt and input out and move it to there. Going to put that clearly indented inside of the while loop. So enter a number, X. You broke it, you monster. Enter a number, J. You broke it, you monster. Enter a number, K. You broke it, you monster. Enter a number, 1.3. I didn't break it, and instead it did that thing that I showed you earlier, where it accepted 1.3 as simultaneously a number, a letter, and then another decimal number. Let me try this again. K, K, K. Okay, why aren't you reading my data? 1. And now it works. And I can put a $sign in here. Actually, I'm going to put 2 $signs in here. And check that out. Once again, it broke. Because here, when it received the $sign, that first $sign went into letter just fine. The second $sign stayed in the input buffer, and it was put into decimal value. And because the $sign was not accepted as a valid decimal value, it gave us this garbage value. We can see this happening in the debugger as well. I'm going to put another breakpoint right here and run this again in debug mode. So the first thing that happens is here in the if statement, it checks to see if cin fails. Cin has not failed, we haven't put anything in there. So let's step in and see what happens. If I step in here, oh, it's one of those crazy, wow, X iOS base. I'm just going to step out of here because I don't really care what that does. And because it didn't fail, this if statement did not trigger, then it's asking me to enter a number. Well, it's not asking me yet, it's just at this line. I'll go ahead and step over so it does ask. There we go. And then I'll try to step over and it's waiting for a value. I'll press the number F. The number F. That's not a number. What happens here? If cin fail, what it's checking here is it's checking if either the bad bit or the fail bit is on. And we don't really need to know that much about the design of cin, but these things basically just determine whether or not the input buffer is receiving data correctly. In this case, one of these two is on, and I forget which one it is. And because it's on, it will return true. Come on, there we go. So because this returns true, the while statement has to loop, because that's the contract you make with a while statement. With an if statement, it runs the code if it's true, and with a while statement, it runs the code if it's true. With a while statement, it will keep running as long as this is true. Whoa, that was a mistake. Which is why it will constantly re-ask us to enter a number if we don't enter a number yet. I'm going to hit step into, and it goes back to the top. Because this was true, it starts right back up, right at the beginning of the do while. Again, it's checking this if statement. This time, however, fail is true, so I'll just step over that because we don't need to see that code, and it takes us right here to the code that triggers if things break. And I'll step over that. There we can see our accusation. And then it clears cin, so it's no longer broken. It ignores the bad data, and it asks us to enter a number, and then we get a chance to enter another number. I'll enter the number 12. This time it is an actual number. 12 is a totally legitimate number, so when I go in here, neither of these are true, and it goes out of the while loop over to the next line afterwards. Okay, so the program is still in debug mode. I'll go ahead and stop that. I've got one more thing that I want to show you guys, how to make a simple menu-driven program. So here we have a program that does three things. It grabs an integer, it grabs a letter, and it grabs a decimal value. Actually, it does four things, and then it prints something out. And we can put this in a menu-driven program like this. First, I'm going to explain the options. Cout 1, enter an integer. 2, enter a character. 3, enter a decimal value. 4, print data. And 5, quit. So this is kind of the menu that my program will have. And the way that I'll implement this menu is with a switch statement. So first I'm going to make a choice variable that I'll get from the user. And based on that choice, switch choice, I will do all of this stuff. And I'll go ahead and indent this here. And in the case that the choice is 1, oh, I should move this float out of the case statement and up here, along with the other variables. So in the case that the user picked 1, it will allow them to enter not break. It will allow the user to enter an integer. In the case they picked 2, it will allow them to enter a letter. In the case that they picked 3, a decimal. In the case that they pick 4, it will do the printing. And all of this will continuously happen the user picks 5. Notice I'm using a do-while loop here. Do-while loops are really good when you know that everything inside of the loop needs to happen at least once, and also if the condition of the do-while loop cannot be known until this code runs at least once. At the beginning of our code, choice has an unknown value, it has a garbage value, and while right here is checking the value of choice. Well, if while was placed at the beginning up here, this code would be legitimate, except that our program might crash because choice is uninitialized. In fact, I think it actually will crash. Oh, look at that. In the debugger, choice has this really crazy value. Look at that. That's not what we want. We don't want it to do that. It's actually not crashing, which is good. And I can, oh, actually it did crash. Look at that. So here, we don't want to use a do-while, or a while loop, just a pure while loop. Well, let me stop debugging. We want to use a do-while loop because choice is initialized inside of the loop. And now it will run like I hope. So every single loop, it will print this out. Enter an integer. If I enter something else like 6, what's going on? Oh, should be a not equal to. My bad. Because of the way that this is set up, it will only loop if I press 5. So I can press 5 and 5 and 5 and 5 and 5. If I press 1, it asks me to enter a number like G. Ah, look at that. There's that code that fixes bad input. Put an actual number in there. And then it quits out. This right here is waiting. It's at the get ch here, waiting for us to finish. Because the while loop says it will only continue if the choice is equal to 5. But 5 should be the only choice that will end the loop, which is why this needs to be and not equals to. So now, if I type 6, or 7, or 12, or 40, it will continue looping. If I press 4, oh, look at that. It's giving me an error because it's using data before it's initialized. When you get this error, it basically just tells you that you should initialize your values. It's usually pretty safe. In fact, I think it's always safe to initialize your variables to 0 unless they're special classes or data structures. Then the rules are a little bit different. But with the primitive data types, it's always safe to initialize your data to 0. So now if I run this again and I press 4, whoa, continue. Press 4, there we go, it prints out our initialized zeros. Quit, and when I quit it does the get ch. I don't really need that get ch anymore. That's just kind of awkward. But if I type in like X here, check that out. It's going crazy because X is not an integer and cin does not accept it, so cin is now broken forever. If I wanted to fix it so that it didn't loop all crazy like that, and by the way it's doing an infinite loop, we can see that my CPU is a little bit heavy right now. One of these is pretty, actually, it's not too bad. Yeah, this one's kind of high. If I close this, it will go back down. Yeah, look at that. Look at that. Yeah, we could fix this if we did a similar setup as we have here in case 1. If you guys want to do that, you're welcome to. Well, I hope that was educational for you guys. Let me know if you have any questions.